Hello, in this video I want to show you how to use a new modifier RayFire cluster in version 1.62. It's purpose to clustering simple fragments into more complex, and it uses geometry element and combine them into the more complex fragments. So first of all I will use a simple box just to show you how it works, and I will assign RayFire fragmenter. You can use any other modifier or any other way to create simple elements. Let's say 400 fragments. So let's turn on RayFire. First of all I will detach them, and as you can see, here's my fragments. You can add them here, and you can see that all these fragments are pretty simple. Each fragment is pretty flat and looks not so real. So this is where you can start using RayFire cluster feature. I'll delete it. Here's another geometry. As you can see, it has much more elements. So here's this modifier RayFire clusters, and by default, after you assigned it, as you can see, there's no any difference. It's because you have to turn on preview, so you'll see what it did. And there's two ways to use preview. It's the scale one. You can scale it, and here you can start see how exactly it's clustering it. So now this fragments now doesn't look so simple. And another way to use preview is assign vertex color using the checkbox. There's another way to see fragments, so you can check it and check it. So let's start from this first group of properties. It's called Gizmo, and here you can see that it supports box Gizmo and spherical Gizmo. The first one has just three properties: width, length, and height. So if you want to clustering only some area of your original geometry, you can decrease the size of your Gizmo using these properties, or you can simply go to this subobject mode Gizmo, move it anyhow you want, and let me move it outside of geometry. So here you can see that each Gizmo has these yellow points. It's called point cloud, and based on this point cloud, it clustering all the fragments into more into clusters. So where a lot of points, there will be more clusters, but they will be less in size. So let's move it back to here, and here are clusters again. So we can rotate it or scale it, whatever. Another Gizmo is spherical Gizmo, because sometimes you may need something spherical, and right now you can see there is only radius property, so you can decrease this radius, and again you can move it. Okay, next group of properties is point cloud. It's actually defines. I will set here to box because it's easier to understand how it works. Let's rotate it back. So first one is uniform, and as you can see, creates pretty all clusters has pretty the same size. Let's increase here's the num points. It means amount of points in point cloud. Let's set here something like 70, and as you can see in uniform, the uniform point cloud, it all the clusters has pretty the same size, not a big difference. So if you want to get pretty uniform clusters, you can use this uniform point cloud. And here's random seed. So if you want to recreate point cloud, you can quickly play with the seed property. And if you want less amount of clusters, you can use this num points, set it to 100. Another second way is to generate point cloud is called point per element. And to show how it works, I will use another geometry. And since, as you can see, this original geometry has fragments. Also, it was also fragmented using uniform fragmentation type. All the fragments has pretty the same size. And to show you second point cloud, I will use this geometry. It's isolated. As you can see, this geometry has very tiny fragments in the center and very big fragments in the borders. So let's assign cluster modifier now and use point per element generation type. Now let's turn on assign vertex colors. And as you can see now, it creates more clusters at the areas where there are more fragments, and big and less and bigger clusters at the borders where big elements are located. And instead of amount of point clouds, now it says max points, because you cannot create points more than elements inside the geometry. This is why it's called point per element. So it uses element bounding box to generate this point cloud. Let's set here, say 50. So here you can see more fragments, more clusters, and there's available this bias property now. It allows you to distribute, to regenerate point cloud, and default value is 0.5. The lowest value is 0 and the highest is 1. And as you can see right now, with highest value 1, it creates even more points where a lot of tiny fragments, and with value 0, it starts creating more fragments, more points near the big fragments. So if you want to get different results, you can play with this bias. And okay, so now let's get back to this geometry. And let's set here like 40 clusters, maybe even less. So okay, now let's talk about the generate clusters group of properties. So as you can see, there are all the elements are inside some cluster. But if you want to preserve some fragments and keep some elements and keep them separated, you can use this percentage property. Right, by default it's 100, which means that all the elements will go to the clusters, and start decreasing it. You can see that at the edges of these clusters, some elements right now are separated, and they are not in any cluster. So you can play with this as well and get some geometry with some tiny fragments not in clusters and some clustered fragments. Okay, got the idea. And now let's see how works maintain connectivity. And to show this feature, I will, let's say, create another geometry, something like this. Okay, now let's fragment it. Now let's assign cluster modifier and turn on preview. So let's set here like 10 clusters. So this is how maintaining connectivity works. When it's off, it may combine into one cluster, since there is only one point, this point here. And as you can see, this green group of elements right now is one cluster, and this brown group of elements also in one cluster. So when I will detach them, I will get these objects connected to each other, but even though they are not connected and there is a gap between them. And when you check on maintain connectivity, cluster modifiers make sure that even if this group of objects belongs to one point inside point cloud, but if they are not connected, it will separate them into different clusters. So by default this property on, and maybe sometimes you may need to turn off it. Okay, now you know how it works. Now let's take a look about this outside of Gizmo property, and to show it I will scale my Gizmo so it will be less than geometry, and let's set here also to spherical, it's easier to see. So right now, as you can see, all the point clouds, all the points inside the spherical Gizmo, and here's my clusters, and default property here is single object, which means that all the elements outside of Gizmo will go into one single object. This will be one big cluster. And there are another two ways. The first one is use point cloud, and in this case it will continue using point cloud, and it will clustering all of the elements even though they are outside of Gizmo. So here's, you can see that here's let's say this cluster. As you can see, this here is the border, here is the border at this side, and here it ends. But if I set here use point cloud, it will continue all the edges. And the next, the last one is separate objects, and in this case you can see it simply will keep all of the elements outside of the Gizmo separated. So when you will detach, you will get these fragments, these clusters, and all of the other elements will stay as is and will be separated and not connected to each other. Okay, set here a single object, and then next oh, also I forgot to show you this custom point cloud. It actually doesn't do anything because it allows you to use Max script to define this point cloud. And if you're familiar with Max script, I'll just show you quickly how to do this. On listener video, you can type in show properties, selected object, modifiers, first modifier. So here you can see all the properties which you can adjust, and here's this PC custom points property. So you can use this property, and if you will evaluate it right now, it's empty, and in the same way you can assign it, say array of 2 points, 0 0 0, sorry, 0 0 0, and another one will be 30 30 30. Can be, let's set 0 0 30, and another one will be 0 0 50. Okay, you can evaluate it using shift enter, and here you can see let's set here box, let's increase it, So here are my MaxScript clusters right now. Obviously I need to add some more points. Let's say 0, 0, 100, and add another one. I can in the same way generate any other, can generate them as point cloud in any way you want. If you're familiar with MaxScript, it won't be a problem for you. And let's say 0, 0, 120. So you got the idea how to use it. Okay, let's set it back to uniform. And so next property here is face selection, and by default it's turned off. It says here ignore, and this feature actually will be improved in the next version, but so far I can show you that using this selection on the original geometry. So let's say I will select this area here, and then I can go back to clusters, turn off selection, activate clusters. So right now it says here ignore. Let's set here multiple clusters, and here you can see that, so you can see there is an H. Since we have selected this area, it separated this area from other clusters and created clusters inside that area. Another way, you can call here single cluster. In this case it will be just one cluster. So here's the cluster connectivity. Basically by default Swallow doesn't take into account connectivity, so if you want to use it with connectivity you have to choose a single cluster with connectivity. And the last one is keep as elements. Now you can see that all the fragments goes into clusters except the selected elements. Okay, let's ignore it. So this clusters group, you already know how it works. It just allows you to scale to see preview, and here's how scale works. Sometimes I found it more easier to use scale to see fragments, and let's make Gizmo less. So here you can see that all fragments outside of Gizmo works a single object, and I can set here scale outside of Gizmo, so all the geometry outside of Gizmo also will be scaled, but by default you will scale only clusters inside Gizmo. Set separate objects, and as you can see they are not scaled. Just check on, it will scale them as well. Okay, and the last group of properties here called export. So here you can export all of your clusters into different geometry, and before do it, do not forget to set scale back to 100, because otherwise it will scale them, it will export them with scale which you see inside viewport. Let's turn on assign vertex colors and set here single object outside of Gizmo. So there is a two checkbox, delete after export, which means that original geometry with cluster modifier will be deleted after exporting. And another one is assign random colors. It allows you to assign to your geometry a random wire color. So let's check off delete after export here, and I can click now. Here you can define this additional suffix for your geometry. So let's say it's called wall, and base name here will be cluster. We can export objects, and you can see they are selected right now. So here our original geometry is still here because we have this delete after export checkbox off, and here are our fragments. So now we can create some animation using these clustered fragments. Select them, add them in this list, and maybe create some bomb. And let's start simulation. increase style. So as you can see, such fragments looks much more real. Okay, thank you for watching, and hope this new modifier will help you.